Okay, let's dive right into this incredible explainer by taking a literal factory tour of your body's internal water treatment and waste management plant. It's a system that runs silently in the background of your life, completely behind the scenes, keeping you alive without you ever having to give it a second thought.
Think about it. Every moment of every single day, your cells are generating waste as they undergo their normal metabolism. If left unchecked, this waste, along with excess water and salts, would literally build up to lethal levels. So today, we're going to explore exactly how your body handles this highly toxic problem and turns your urinary system into an absolute everyday hero.
Here's our roadmap for today. First, we'll meet your excretory system. Second, the kidneys, our master filters. Third, we'll look at the microscopic magic of the nephrons. Fourth, the ureters, which are the transit tubes. Fifth, the bladder, our expandable reservoir. And finally, number 6, the urethra, the final exit.
Let's jump into Section 1. Meet your excretory system, the big picture.
You know, your body actually has 4 distinct excretory systems. While your bowel, your lungs, and even your skin also excrete waste, our focus today is squarely on the urinary system. This relies on 4 main components: 2 kidneys, 2 ureters, a urinary bladder, and urethra. It is a beautifully streamlined plumbing system designed with one overarching goal, which is filtering your blood and safely removing waste products to the exterior.
Moving right along to Section 2, kidneys, the master filters.
These reddish-brown, bean-shaped organs sit right up against your posterior abdominal wall, basically your lower back. And interestingly, the right kidney naturally sits just a slightly bit lower than the left one. Now, for such vital organs, they are surprisingly compact. Honestly, they're only about the size of a standard computer mouse. At roughly 11 centimeters long and weighing just 135 to 150 grams, they are responsible for a truly incredible volume of work.
Because these organs do so much heavy lifting, they can't just be floating around unprotected, right? So they are heavily shielded by 3 specific layers. The innermost is a fibrous true capsule, which is then surrounded by a middle fatty periniphric capsule. That fat acts as a literal built-in shock absorber to hold the kidney firmly in place. Finally, the outermost false capsule actually merges with your diaphragm, which means your kidneys are literally moving up and down every single time you take a breath.
All right, Section 3, nephrons, the microscopic magic.
Okay, I want you to just let this number sink in for a second. 1 to 2 million. That staggering number represents exactly how many microscopic units, called nephrons, are packed into each and every single kidney you have.
So the crucial point here is that these millions of tiny structures are where the actual magic of separating life-saving chemicals from toxic waste occurs. A nephron works through a highly sophisticated 3-step process. First up, blood is filtered at the glomerulus. Then, as the fluid travels through these twisting tubules, the nephron reabsorbs all the useful chemicals and water your body still needs. Finally, it secretes the remaining waste right out. It's an incredibly selective sorting process that's happening millions of times a second.
But hey, if you thought nephrons were just there to make urine, you'd be missing half the story. These tiny workers act as a master chemical control center. They secrete an enzyme called renin to strictly regulate your blood pressure and blood volume, and something called erythropoietin, which actually tells your body to make more red blood cells. They manage your blood's pH and acid-base balance, and they even detoxify free radicals and drugs. Your kidneys are really doing so much more than just basic waste disposal.
Next up is Section 4, ureters, the transit tubes.
Once the nephrons have done their job, that resulting waste fluid needs a highway to travel on. Enter the ureters. They are a pair of thick-walled muscular tubes that actively push the urine downward. They're about 25 centimeters or 10 inches long, but incredibly narrow, only about 3 millimeters in diameter. And they feature 3 specific choke points where they naturally constrict even further, as they leave the kidney, at the pelvic brim, and right as they pass through the bladder wall. These natural constrictions are absolutely crucial to know medically because these are the exact spots where a kidney stone is most likely to get lodged.
This brings us to Section 5, bladder, the expandable reservoir.
You might find it totally fascinating that exactly 220 milliliters is the specific fluid volume threshold that finally triggers your conscious desire to micturate or, to pee. The bladder itself is a highly muscular, hollow reservoir lined with transitional epithelium that allows it to stretch out. As it fills past that 220 milliliter mark, stretch receptors fire off signals straight to your brain. Now, while the bladder can technically tolerate filling up to about 500 milliliters, hitting that half-liter mark becomes, quite painful.
Now, normally, the inside of an empty bladder is full of wrinkles, or mucus folds, that just flatten out as it fills. But inside this muscular balloon, there's one really unique exception. On the posterior wall lies a permanently smooth triangular zone called the trigon. There are absolutely no mucus folds here at all. At the two upper corners of this triangle, the ureters enter to drop off the urine. And at the bottom point of the triangle is the internal urethral orifice, where the exit path begins. It basically acts like a perfect built-in funnel.
Finally, we reach section 6, urethra, the final exit.
The urethra is that final channel to the outside world, but there's a massive anatomical difference here based entirely on biological sex. The male urethra is approximately 20 centimeters, or 8 inches long. The female urethra, however, is significantly shorter, measuring only about 3 to 4 centimeters, or 1.5 inches long. This vast difference in length actually explains a major medical reality. It creates a much shorter path for ascending bacteria, which makes females significantly more susceptible to urinary tract infections.
But before waste actually leaves the body, it has to get past security. Your body perfectly balances this exit point through two specific gates, or sphincters. The internal urethral sphincter is made of smooth muscle and operates completely subconsciously. It's totally involuntary. However, wrapped around a little further down is the external urethral sphincter. This one is made of skeletal muscle, and it gives you voluntary, conscious control. It's this external gate that allows you to decide exactly when it's appropriate to empty the reservoir, perfectly harmonizing an automatic bodily function with your own conscious will.
So we started with the blood pumping into the kidneys, and literally followed it all the way out. Millions of tiny nephrons filtering your blood, balancing your pH, and regulating your blood pressure, all while funneling toxins down the ureters into a stretchable tank, carefully guarded by conscious and subconscious gates. I'll leave you with this final thought to ponder. How incredible is it that this non-stop, highly automated internal factory is working relentlessly inside you right at this very moment, keeping your internal chemistry absolutely perfect without you having to lift a single finger? I hope you walk away with a profound new appreciation for the silent, microscopic magic happening inside your body every single day. Keep learning, and we'll catch you on the next explainer.